Manufacturing and industrial environments provide their own unique challenges for wireless communications. Harsh conditions, both indoors and out, create a daunting task for engineers to work through. This is where we come to discuss those challenges, share ideas, and help one another out. My name is Scott McNeil, and welcome to the Industrial Wi-Fi Shop. Welcome everybody to the Industrial Wi-Fi Shop. I am Scott McNeil. Today we are going to talk about Bluetooth and more specifically, mostly about Bluetooth Low Energy, BLE. And we will get to the industrial applications of that, but we're going to talk about all kinds of Bluetooth stuff today. With me today is fellow industrial wireless rodeo clown, Jeremy Baker. Say hi, Jeremy.
Hello, everyone.
He's a man of many words. So Bluetooth is everywhere. You can't swing a dead cat and not hit something Bluetooth. Not that you should be swinging dead cats to begin with, but Bluetooth is everywhere. Whenever I go on site and I run spectrum analysis, I'm always seeing the telltale signature of Bluetooth traffic on its advertisement channels. It's I don't care if it's pulp and paper, if it's specialty chem, if it's discrete manufacturing. I see it. So I thought it would be a good idea to do kind of a fairly deep dive into Bluetooth, its mechanics, and what it does for industry and manufacturing. So right off the bat, I gotta say, I have been telling everybody for a long time, and that Bluetooth was 802.15.4, and man, I'm so wrong. I'm just wrong. It is not 802.15.4. IEEE actually standardized it as 802.15.1, but they don't even maintain it anymore. Bluetooth as a standard has been fully managed now by the Bluetooth Special Interest Group for quite a while. And last I checked, there are over 35,000 member companies of the Bluetooth Special Interest Group. I mean, that's just ridiculous. That's a lot of companies that have input onto this standard. And Jeremy and I were talking just a few minutes ago. That kind of gives it a pseudo open source feel, doesn't it, Jeremy?
Yeah, it definitely feels like there's a lot of people with kind of a vested interest to keep it working and maintain it. So it's kind of like a free developer group for the standard.
So as of 2021, and so as of several years ago, actively being shipped were over 4 billion Bluetooth integrated chipsets annually. Now that's as of 3 years ago in 2021. I can only imagine what it is now. It's got to be off the charts. Let's just go ahead and dive into some of the fun geeky stuff for all of us wireless guys. It's pretty, everyone, it's pretty common knowledge that Bluetooth and BLE are in the 2.4 gigahertz frequency range. They run from 2.4 all the way up through 2.4835 gigahertz. However, they have guards or buffer bands at the top and the bottom, and the bottom one is about 2 megahertz wide, and then the top is 3.5 megahertz wide. So the actual frequency that it's using is 2402 through 2480, with those buffers being there to help adjust for interference. Now, when it comes to Bluetooth, you've got kind of a couple different kinds. You have what they refer to as Bluetooth Classic, which is anything before version 4.0. And then you have 4.0 and up, which everyone knows is Bluetooth Low Energy, or BLE. Channel-wise, Classic has 79 channels that it uses, and they're all like 1 megahertz wide. There's no overlapping channels. When you're looking at BLE, it changes that up, and it's using 40 channels at 2 megahertz wide. So the two are not compatible with each other due to channel structure, if nothing else. But also they use different modulations, but we'll get into that in a minute. With these different channels, you also have, which they utilize going across, they also have advertisement channels that they use to cue in what they're going to do back and forth from device to device. And these channels are referred to as primary advertisement channels. They're numerically listed as 37, 38, and 39, though they are actually not congruent through the usage channels, which is kind of funny. So channel 37 is 2402, channel 38 is 2426, which is like roughly in the middle. And then channel 39 is 2480 right there at the top of that range. So that what that really does is that leaves 37 channels in BLE actually open for data usage, which that's a lot of channels when you think about it for hopping data across. The modulation of these guys, that's a big part of the evolution of Bluetooth. And so modulation for this kind of just directly translates into data rates. So when looking at like classic Bluetooth and the original Bluetooth that just came out, they were using what is referred to as GSFK, or Gaussian frequency shift keying modulation. I'm not going to get into all the details on that, but it is said to be operating at a basic rate. So that's what Bluetooth calls their basic rate is the GSFK, and it's up to about 1 megabit per second. So that's all your classic stuff, your old school headphones and mice and Bluetooth keyboards and different things like that. When you got to later versions around 2.0, they changed up going from frequency shifting to phase shifting. So 2.0 all the way up to 4.0 uses differential phase shift keying, or variants of that, modulation wise. And then Bluetooth considers that an enhanced data rate, or EDR. So you might actually on your device see an EDR designation. And so EDR effectively doubles the data rates, or can even triple. So in this case, they have different designations. There's an EDR2, and then there's an EDR3, and they are 2 and 3 megabit max rates, respectively. Now, Apple, because Apple is Apple, in 2019, they came out with their own extension that they published, and they refer to it as HDR, and it's using phase shift keying, but they take it a step further, and they refer to it as differential quadrature phase shift keying. Easy for me to say, right? And so the shorthand it's referred to as HDR, but they got two versions of it. There's HDR4, and then there's HDR8, and max theoretical on these guys is 4 and 8 megabit respectively. Now, I don't have any Apple products, so I couldn't vouch for the overall data throughput that those things are pushing through with classic Bluetooth, or well, 2.0 to 3.0. But when you look at the power levels associated with that, I don't know. I have a hard time personally believing it can get to those max theoretical data rates. But I don't know. That's me. I'm a skeptic. Once you start hitting 4.0, which is BLE territory, your data rates reduce again. So Bluetooth 4.0, in the 4 range, they're up to a megabit per second. And then Bluetooth 5, which is relatively recent, they have increased that up to about 2 megabit per second as far as theoretical throughput is concerned. But when it comes to the range of all this stuff, range of the Bluetooth classes is actually based upon class, and class is based upon power levels. The problem is there's a lot of conflicting data on this due to sales and media hype from different device manufacturers. And we should be used to this in the wireless community anyway, because everybody's quick to jump on the max theoretical bandwidth and range, every time a new revision of wireless comes out. Well, it's no different with Bluetooth. So it's really kind of hard to pin down exact ranges on these different things. So I did a lot of research, and really kind of the best that I could come up with are essentially kind of averages. So with class 1 devices, are like your most powerful Bluetooth devices, and they can range, according to the standard, anywhere from 10 to 100 milliwatts. So For something that's called Bluetooth low energy, 100 milliwatts, that's pushing a lot of power, if you ask me. The range is generally considered to be approximately about 100 meters, and I think that's dependent upon a lot of different factors, to be honest with you. Now, BDR and EDR devices, like we talked about a few minutes ago, they're loosely kind of called a class 1.5. Um, Although they are technically considered a class one, the power levels they use are anywhere from 2.5 to 10 milliwatt, with a max theoretical range of approximately 50 meters. So those are your enhanced classic Bluetooth, which gives you a little bit of a higher data throughput. And that's your modulation plus your power that you're adding to it is what I'm getting out of all that. Class 2 devices, which is all of your classic Bluetooth, your basic rate stuff, power ranges from 1 to 2.5 milliwatt, and this is by far the most common of what's out there for end user devices. And the range is about 10 meters, 33 feet. Your mice, your keyboards, headphones. You walk 20 feet away, and they start staticking out or dropping out. BLE is a little different. You're getting with BLE4 a max theoretical range of about 100 meters. It is a class 1 device. But BLE5, which is, again, relatively new to the scene in the grand scheme of things. Granted, it didn't come out yesterday, but it hadn't been out for too terribly long. They're claiming that the max theoretical range is approximately 400 meters. Now, I am a skeptic when it comes to that, because that's a long way for what is considered a low energy device. Now, granted, it could be maxing out the power levels at 100 milliwatts. I don't know. But as with any of these ranges, it's important to note that no matter the class of the device or the modulation that it's using or the theoretical range that it should have, the environment that you're deploying these in is going to play a very, very important role on your actual real world range and data throughput. So as with Wi-Fi, you got to take a lot of this stuff with a grain of salt until you see how it's going to react in the area that you want to deploy it in. So let's move into reliability. So one of the things that makes Bluetooth so attractive to a lot of IoT devices, IIoT devices, and honestly, personal area network devices, is the fact that it's so robust, can get the data through, so you get that uninterrupted experience. When it comes to personal devices with audio and video and whatnot, but on the IoT side with actual production data and things like that. And its primary function for reliability is what is referred to as adaptive frequency hopping, AFH. And I kind of dug fairly deep into this because I was really interested on how this works. So apparently, AFH, it takes the individual message and it breaks it down into small data packets, which are sent over different channels. But it's kind of a predefined sequence. It's pseudo random. And that pseudo random sequence is known only to the transmitting and receiving devices. As many as 1,600 channel switches can take place every second. So stop and think about that. Every second, conceivably, you could be hopping channels up to 1,600 times if need be. On top of that, any data packets that don't reach their destination are resent. So if there was a problem caused by the channel, it gets flagged, and that channel is then avoided for future transmissions as it starts updating its AFH tables. So in really noisy environments where data is transmitted over longer distance, there's also a chance of bit errors kind of slipping into the messages. Well, Bluetooth can also take action to avoid unreliable channels if that's the cause, which we were just talking about, and start what's referred to as channel blacklisting. So then it just takes it out of the mix. So we know that there's interference there. Data's not getting through when I use channel 13. So we're not going to use 13. We're just going to take that out of our pseudo random mix, right? And then they also built in FEC, forward error correction, to rectify errors once data arrives at the receiver. So for those who are not familiar, forward error correction is a digital signal processing method. It reduces the bit error rate of communication by adding parity bits. So just like with downloads from certain secure sites and whatnot, you have parity checks. It's a similar process. The data at the transmitter side adds parity so that the receiver side can then use those parity bits to detect and correct errors that may have been introduced over the course of the transmission. So that's a lot that Bluetooth is able to do to ensure data reliability, which again, that makes it ideal for IoT deployments and IoT deployments. And that's why you see such an explosion over the past 5-6 years of these devices everywhere, from, I don't know, from smart buildings to hospitals to higher education, and of course the explosion now of IIoT, or industrial IoT devices. So we've gotten through all of that, right? And we've got our reliability. We've figured out our distances. We've figured out power ranges. We understand how Bluetooth can transmit all of this reliably. Well, what about security? So security is always an issue, right? There's I know everywhere you look, the common term for the main vulnerability is bluejacking, where someone just kind of intercepts and becomes part of your Bluetooth network. As Bluetooth has evolved, the security measures have evolved with it, and so really you have to have some sort of jailbroken Bluetooth device in order to be able to get into this anyway. So one of the main security features is actually that adaptive frequency hopping that we talked about a few minutes ago, because only the transmitter and the receiver know and understand what that pseudo random sequence of channels is going to be, as well as any sort of blacklisting that's going along with that. So really the main vulnerability that you're going to get with Bluetooth is during that pairing process, or if you have a device that can actually listen to the Bluetooth traffic itself, which is not as common as one might think. I'm not saying they're not out there, but it's not something you're going to go to Walmart and pick up off the shelf. Now, Bluetooth 4.2 and up use different pairing mechanisms that can prevent data in transit from being vulnerable to man-in-the-middle attacks and bluejacking. So once connected and paired to target devices, BLE can then be put into a hidden or invisible mode. Well, that's kind of like any device really these days with Bluetooth can be put into like a hidden mode. I kind of compare that to hiding an SSID with Wi-Fi. It's kind of security through obscurity. I'm not necessarily saying that's really going to be or that really is like a valid security method, because you're still going to see MAC addresses when you have devices that can sit there and detect Bluetooth traffic. But that doesn't necessarily mean you're going to see it as a connectable device. So there could be some really minor security bonuses to that. I'd like to take a moment to thank our sponsor for this episode, Global Process Automation. GPA is an engineering and technology firm based in North Carolina, serving clients in industrial processing and manufacturing, focusing on solutions for industrial automation, operational technology infrastructure, industrial control systems, cybersecurity, manufacturing intelligence, and analytics. For over 25 years, their clients have entrusted them with their processes to maximize their company's efficiency and obtain an optimal ROI based upon their assets while protecting their operational technology resources. GPA's mission is to automate, optimize, and secure manufacturing floors everywhere while maintaining their core values to have integrity, to continuously improve, embody their community, remain customer focused, and implement great teamwork. Thanks, and back to our show. But what's really interesting is there are with BLE, they have what are referred to as security levels, and I found this really great article online. I'll link it in the show notes on allaboutcircuits.com. And they had a really good breakdown of Bluetooth security in general, a lot of nice graphics and everything, but some solid explanation to things without getting overly technical. It's kind of easy to understand. And this is how they break it down. So security level one is no security. So there's no authentication, there's no encryption, but on the flip side of that, it's super easy to pair and set up, right? To get two devices connecting and talking. Your configuration time is absolutely minimal. You're up and running, everybody's happy, communication's going on, right? But you're vulnerable to everything. You're vulnerable to those who can listen in on Bluetooth traffic. You're vulnerable to man-in-the-middle attacks, bluejacking, so on and so forth. Then they get to security level 2. Now, security level 2, what they do is there's no authentication for device pairing, but once things are paired, they do encrypt. So there's no authentication, but we add encryption. And most devices, if it's running by the Bluetooth standard, are using 128-bit AES, but the pairing is still vulnerable. I kind of compare this to a WPA2 deployment, but with no management frame protection, if that makes sense. All of your handshakes and everything are clear text you can see and capture, which makes you vulnerable to multiple different attack styles. But then after that, your data is all happy and encrypted once that initial connection is taken care of. So I kind of equivalate. Is that even a word, Jeremy? Equivalate. I equivalate sec level 2 to a standard WPA2. I'm sorry, I stepped all over you. What'd you say?
I think you're saying equivocate, but yeah,
Equivocate.
I mean, we make up words all the time.
A brother got to do what a brother got to do, right? You knew what I was talking about.
Yeah, this is interesting. You got my attention, so I've been quiet.
So then we move into sec level 3, which is where they add authentication into the pairing with the encryption after the fact. So there's a couple different methods they use for authentication. Pairing is protected either by using out-of-band association. So you're actually using a different method to get two devices talking to one another, as opposed to having them directly connect wirelessly. That could be through a USB key. It could be through manual configuration, or it could be, connecting wirelessly, but using a passkey method in order for the two devices to start talking and then get their encryption, which then that eliminates man in the middle and bluejacking if you have a significant enough complicated passkey. As with any sort of passkey password, if it's not complex enough, it's going to be easily broken, right? Then they have what I refer to as their MAC adding, that's sec level 4, and that's really for BLE, and they actually refer to it as authenticated LE secure connections pairing with encryption using a 128-bit strength encryption key. All right, so that's a really long sentence. So essentially, what they do is they take sec level 3 and they're using the passkey method, but that passkey, they're encrypting with 128-bit strength encryption, right? So that's kind of like going to your, if we're talking, if we're looking at equivocating or equivalating or being some kind of equivalent, I would compare that Wi-Fi wise to kind of like WPA3, where management frame protection is mandatory and it has made adjustments to its encryption algorithms and whatnot. But again, that's for BLE, so that's you're only going to see that in Bluetooth 4.0 and up. So that's a lot to take in. What do you think, Jeremy?
Yeah, that's definitely more than I thought possible. A couple things that kind of stood out to me from what you were saying is that to go kind of way back is that max theoretical is for customers and salespeople. And, that's the scariest thing is the document says it can do 1 billion gigawatts of throughput.
Why is my
Um,
deployment not getting 1 billion gigawatts of throughput? Yeah.
yeah, we've got several of those. And the adaptive frequency hopping is kind of interesting because I'm not, I know you do a lot of like the 900 megahertz stuff, but you don't see a ton of that. So I bet the spectrum analysis on that would be pretty cool. And
Um,
a lot of this, have you ever run any of this stuff over like control systems? I've seen a ton of it in like sensors, and I know at like entertainment parks, people will put these beacons out that, like rogue beacons. And so then there's people that have to go around like sweeping for them.
well, that's a kind of a great segue into what I was getting ready to get into, and that's functionality and use cases for industrial manufacturing, and really that's the biggest thing I see Bluetooth out there for is sensor packages, right? But it's funny, and I don't have one, but I see them all over the place. Is the Bluetooth serial adapters for like logging into switches and stuff like that for console ports. And it didn't click in my head, but BLE has a serial port profile emulator built into it, and it's a full serial interface, complete with hardware handshaking via Bluetooth. So there is a lot of use cases out there where Bluetooth is creating wireless serial connections for control devices. So it's kind of like close range wireless IO, remote IO for manufacturing, which is very similar to what Wireless Heart and ISA 100 do. So it's interesting, and my brain never put the two together. But oh yeah, that's a serial connection right there for my console port. I didn't realize they actually had it defined as a serial port profile, which I find incredibly interesting. But that also makes it very useful, but not only for manufacturing, but also like smart building applications.
Yeah, for sure. I imagine that there's probably even, some of these parking lot robots or things like that, things that might need to kind of ingress or egress buildings could take it. I'm picturing a lot of stuff that you could kind of do on the back end with that somebody above my pay grade would handle implementing.
You couple that with all of the reliability techniques that are built into Bluetooth, it does make it ideal for a variety of wireless sensor types, and that can range from level sensors in tank farms to preventive maintenance applications like vibration, temperature, and moisture sensors on machinery. That can become effective predictors for preventive maintenance, so that you can get out there and get parts changed before something breaks, which that's a big money and time saver right there.
Yeah, definitely. I was looking at some of these things too, where it's like in maybe some, I don't want to say lower stakes, but some smaller like crane applications where maybe you're not doing something like molten that could necessarily kill somebody or something, but you've got like a moderate shop that you need to move parts around like this. I think this would be a great option to be able to try and run stuff over that.
I mentioned smart buildings, and there's a
Mhm.
lot of applications there for smart buildings. But smart buildings is not just enterprise. I mean, smart building applications are making their way into the industrial sector. Especially when you look at clean room manufacturing. Where it's for pharmaceutical or electronics. You need to make sure temperature and humidity and air quality values are all staying constant, right? And there's even sensors for sensing occupancy of a room so that they can further adjust temperature and humidity. Isn't that crazy?
Yeah, the like the people tracking and stuff. I mean, it's definitely like using this and geofencing and things like that to for clean room stuff too. Like, you were picked up here, but you didn't egress from the wash and wipe down station. You get a little buzz that says, hey, go back through. Or I mean, yeah, there's a ton of stuff that this could do.
Well, and then things you're probably seeing in your in homes and whatnot, but also is great for smart buildings and industrial buildings, and that's wireless thermostats and automated lighting controls. That's a whole. I mean, you could do an entire episode on just automated lighting controls. I had no idea what a rabbit hole that is until I started doing some digging. That was kind of crazy. But the other big thing that Bluetooth is known for is RTLS, right? And location tracking. When you look at how many standard enterprise radios have BLE beacons built into them, specifically for RTLS, right? That has definite uses in manufacturing and in warehouses for asset tracking and location. But another aspect of that not a lot of people talk about, but hospitals use, and actually a fair amount of hospitality uses, are personnel tracking throughout the building, especially when it comes to industrial manufacturing, is being able to not only track personnel in hazardous locations, but when they have the right other hardware built in, they can also maintain or be the connectivity piece for health sensors. So, respiratory rates, blood pressure, heart rate, heart monitor and thing like that for people who are in hazardous locations. So if it's a high heat, high humidity area and they can only be in there for so long, that they have the sensor and they got somebody on the radio, all right, it's time for you to get out. And then I'm sure you've experienced this, being a fellow industrial monkey like me, is hit knots when you're running around warehouses and having to watch out for PIT and fork truck traffic so you don't get run
Oh yeah,
over. A lot of that is Bluetooth based.
yeah, interesting.
Um,
Yeah, I love as much of a pain as it can be. Anything that can save somebody's hands or body or protect us when we're out there. I mean, I love that stuff.
the really last example or kind of use case I've got are robotics and industrial mobility for automated guided vehicles, autonomous mobile robots. I believe they're called AMRs, and cobots. Have you ever dealt with cobots, collaborative robots?
I've seen them. I haven't directly worked with them.
Oh, I was hoping you had, because I've seen them too, but I haven't. I haven't actually got to do any hands-on with them. But all of these machines, they require local connectivity for navigation within dynamic environments, right? Robots can take task or route updates at any point with either a direct Bluetooth connection between the machine and a user's mobile device, or even a Bluetooth enabled HMI, or for the non industrial people, HMI is a human machine interface. It's essentially a screen with controls on it that's specially developed for the machines that it's controlling. There you can have those direct connections, but conceivably you could also have it connected up to a Bluetooth mesh in order to receive those updates, and it can get OTA updates as well. So the utility of Bluetooth in general obviously has proven itself over time. When we're talking about those billions of devices that are shipped every year with Bluetooth integrated chipsets, over time, watching it move into all of these various verticals, it's pretty impressive.
Yeah, I definitely think so. It's the RTLS aspect too, especially like hopefully the cost comes down on those because those are really interesting projects. And it's like every time you get somebody approach you about it, you go, yes, it will work and it'll work really well, but you're not going to like the price tag on it.
Agreed.
Yeah, I mean, it's just the
Well, I guess it also too depends on whether you're doing RTLS on radio and beacon based, or if you're using tags, right?
mhm.
Because tags, BLE tags can be fairly inexpensive if you're not having to do mass quantities of them, right? If you're only looking at 100, 200 tags, that's one thing. But if you're using it for a warehouse full of everything, then you're looking at, thousands and thousands of tags, and that's where the costs
Yeah, it's
start
usually
getting
it's yeah,
astronomical.
it's usually something like that. And then it's like, oh, and this thing leaves the warehouse or whenever, like the fear is that they're not, the people are not going to be able to extract those tags for repurposing.
Right. And so then how many tags you got to look at that you're losing a year that you just have to flat out replace?
Mhm. And that's similar with kind of with RFID gateways and stuff too, is where it's like it sounds monumental, and then and in some instances the ROI is just not there to get it.
Right. Well, and one aspect of this that I haven't even touched on is battery life for these things for those that don't have direct power sources, right? And that was the big thing with BLE is they engineered it to and honestly, I was making fun of the whole it was called BLE even though it could be 100 up to 100 milliwatt power transmission. BLE was really designed for battery powered devices out in the field, so they use a lot of sleep timers. So it wakes up for X amount of time, does its
Mhm.
transmission, gets its update, then it goes to sleep until it's predetermined time to wake back up and whatnot to help preserve battery life. And that's only become more efficient with every evolution of Bluetooth as it comes out. But it's also that way with a lot of other IoT style transmission devices is the sleep timers. So that's a fairly common thing.
Yeah, no, that's been pretty big with like the Halo stuff too, where it's like the DTIM on them, where they and just the which it's kind of interesting, like at scale, like how much energy you can save on this stuff.
Well, it is
Have
because you can potentially out of the device, if you have your transmit times and schedule set right, you can potentially get 2 and 3 years before you have to go swap a battery. And that alone is pretty impressive that you have a sensor out on a tank out in the, out in the middle of your industrial center. And, once every 2.5, 3 years, you got to go out and swap a battery on it. That sure as hell saves a lot of money versus trying to get it hardline powered.
Yeah, because it's I mean, you don't well, most people don't think about, as their special protective equipment you've got to wear to get in there. You've got to schedule time to like lock down some of these areas to access those sensors too.
Yep,
And so, I mean, that's where the real cost is, or the real cost savings comes in.
absolutely. And even then to perform maintenance on some of things, using a tank as an example, you have confined space permits you have to get specialized people who are trained to work in those confined spaces to even, get into the sensor packages. So it's,
Hmm.
and a lot of these things, you don't want to run direct power to something inside one of those tanks. That itself could be a hazard.
Yeah, for sure. And I mean, to step back to my previous comment about safety too, it's like the less of that a person has to do, the safer in general that they are. And so
I,
I mean, it's
I totally
huge.
agree. In general, what a lot of people don't understand is that in broadly in industry and manufacturing, kind of across the board, safety over the years has become a cultural built-in aspect, and everything is done around safety. There's entire departments dedicated to safety because nobody wants any loss of life, nobody wants any loss of limb, nobody wants anybody getting hurt, right? Not only for the quality of life changes that happens along that, but there's a lot of financial difficulties that come along with that as well. Not
Hmm.
only for the business, but for the individual or that individual's family. So safety has really been built in culturally now over the past 20, 30 years specifically. And when you have devices that can cater to that, that just makes it that much better.
Yeah, I'm picturing, some of this like these people trackers and stuff where it's like you've got somebody that's got, an O2 tank or, body temp, wearable sensors, and then you've got that person is like a little, human AGV in a sense, right? Because then
Right.
they're a little remote IO point that's out there, and so it's something that's reasonable. You can power it with a small amount of battery, and then track multiple things from that person, and you've got the simultaneous connection ability.
Yeah, I was at an ore processing site, and they were one of the things that they were going to implement once I was done with my assessment of the site was personal body sensors for people working in very specific areas due to high heat, so that they could measure body temperature and say, and get warnings and say, look, it's time for you to get out of the area, go take a break, go do whatever you need to do, and cool down, because elevated body temperature leads to all manner of different health problems. So, and the last thing, again, because it's safety has become ingrained in the manufacturing culture, and anything that they can do to help support that is good for everybody.
And not to change gears, but here's a Bluetooth blooper from my wireless career. Have you ever had to go back and resurvey a site because you wore your Bluetooth headphones while you were surveying and you created a ton of interference?
I have not. I have not had to resurvey a site, because I generally make sure I have everything disabled so my recording device is getting clean as possible.
Oh, well, I didn't know any better when I first started, and my boss said, "Hey, there's a whole lot of interference here." Whoops.
Well, I was lucky, and I had
a
a few
small
good
size.
mentors who gave me some advice, about that prior. So,
Yeah, well, I only needed to learn that lesson one time.
yeah, that's typically all it takes is one time for something like that. Experience is the best.
But it does kind of go to show where you don't really you don't really think about these things, or we do because we work with it regularly, but you don't really think like, oh, this is like talking at the same pitch, or it's harmonic, or it's resonant in the same kind of musical note, if you will. And so it can kind of how the interference and stuff works, because you just think, oh, well, these I take these headphones out and I put those in and they talk, and why does this other thing act up?
Well, fortunately, there's a lot of great material out there if you want to learn more about Bluetooth in general. Actually, Francois from Clear to Send, on his Semifo Networks blog, he's got a great breakdown of advertisement channels. In the show notes, I'll make sure I link that. There's a lot of good information. A lot of what I was talking about today, I've got the source links. I'll be posting that along with it. I've got a spectrum capture that I did at a site that clearly shows heavy traffic on the advertisement channel. So I'll make sure I put that in the show notes as well. A lot of great information out there. This is stuff that wireless guys in general need to know about, if nothing else, how to help enable coexistence, which, thanks to adaptive frequency hopping, even though it's using 2.4 like Wi-Fi, does have a really high coexistence factor with Wi-Fi, because it can sit there and blacklist those channels, provided that you're sticking to a standard of using 1, 6, and 11, right? Because then they can squeeze in their channels in between those. Now, if it's in an environment that's, total loose cannon, people don't care, they're eating up every Wi-Fi channel and stepping on themselves, they're going to start stepping on Bluetooth as well. And in extreme cases, if there's like a crap ton of Bluetooth, it can start affecting Wi-Fi. But I haven't really run across that personally. I've heard stories from others where Bluetooth was causing a lot of interference and stepping on Wi-Fi. But I personally haven't really seen that. Have you?
Not too much. The biggest like 2.4 interferers we see are usually like smart TVs and smart vending machines.
But they're not using Bluetooth though, are they?
They're usually just a data 211 client.
Well, Jeremy, hey, thanks for hanging out with me on this one and talking some Bluetooth. I appreciate it. I'll be posting all these sources for my material in the show notes. And thanks for dropping by, my man. I appreciate it.
You got it, man. I got it straight from the horse's mouth.
Did you just call me a horse? All right, have a great day, my man. Thanks for listening, everybody, and we hope you join us on our next episode of the Industrial Wi-Fi Shop.